Good morning, my dear children. Good, very good. Today we are going to the new topic about methods of producing induced EMF. Already we have discussed a few topics in previous class. In last class, maybe mutual inductance between two long coaxial solenoid, and we get the point of whereas M12, which is equivalent to M21, it belongs to capital M, which means mutual inductance between two long coaxial solenoid, almost same. Today we are going to see the methods of induced EMF. Yes, already we know that, which means EMF means electromotive force. It is the characteristics of any energy source which can be used to drive the electric charge around a circuit. We have already seen that electromotive force is not only a force, it is only a character. So, with the help of electromotive force, the work done is moving unit electric charge around the electric circuit, and this unit is measured volt or joules per coulomb. For some example, solar cells and electric generators, thermoelectric devices. These are the generators are most powerful machines. They are large scale power generations. And we know that now we are going to see what are the factors to producing of electromotive force by the process of induced method. According, we know that Faraday's laws of electromagnetic induction, the EMF is induced in a circuit when magnetic flux linked with changes. So the EMF is called as induced EMF. Therefore, the magnitude of the induced EMF is given by epsilon equal to d phi by b dt. Whereas here the magnitude of the induced EMF is given by epsilon equal to d by dt of, whereas phi b represents as BA cos theta. So we can generate the EMF by changing of the magnetic field B and area enclosed by the coil E, and theta. Theta represents as by changing the relative orientation of the coil with the magnetic field. These are the method to producing of induced EMF. This is an important two more questions. It may be asked frequently. What are the methods of producing induced EMF? So we can using these equations of 4.17 by changing of d by dt. By changing tells us d by dt. B represents as magnetic field, A represents as area enclosed by the coil, and theta represents as relative orientation of the coil with the magnetic field. The first method we go to see production of induced EMF by changing the area of the coil. First of all, consider a length of the rod is represented as L. We go to the diagram simply. Yes, this is. Let us consider the conducting length of the rod is represented as L. And the rod AB moving towards the left on the rectangular frame. This is a rectangular frame. So the rod AB, this is the length of the rod AB. The rod AB moving left side of the rectangular frame. So the whole arrangement are placed in a uniform magnetic field whose magnetic field lines are perpendicular directed into the plane of the paper. So when the rod is moves from AB and reaches to DC, a time duration dt. The area enclosed by the loop and hence the magnetic flux also decreases. The area decreases and also the decreases of magnetic flux. So now we can find the change in magnetic flux at time duration d. So change in the magnetic flux d phi b equal to b into change in area, which means dA. So magnetic field B and change in area represents as the rectangular frame of ABCD. Since area ABCD is length into the frame of reference, which means the length of the rod moves left 2 ounces of the velocity of V at time duration dt. So we are putting the terms of V into dt. So the d phi can be written as B into L into V into dt. So we are dividing both sides of dt. So d phi by dt into BLV by dt, the dt term and dt term will be cancelled. So remaining d phi b equal to BLV. We know that according to the Faraday's laws of electromagnetic induction, d phi by dt tells us the magnitude of the induced EMF. So we get the equations d phi by dt equal to E represents as epsilon. So epsilon E equal to BLV. This is an EMF, motional EMF, since it's produced due to the movement of the conductor in the magnetic field. The directions of induced current is to found by a clockwise by using a Fleming right hand rule. And next, an important 5 more questions. Production of induced EMF by changing relative orientation of the coil with the magnetic field. So first of all, consider a rectangular coil of turns of N kept in to be a uniform magnetic field. The coil rotate in the directions of anti-clockwise direction. This tells us the figure 4.24. The coil will be rotated in anti-clockwise direction. Beginningly, the coil in the state of vertical to the magnetic field, and the coil is rotated in anticlockwise direction. Omega tells us angular velocity. At time t, the plane of the coil is perpendicular to the field and the flux will be linked its maximum value, whereas phi m equal to BA. At the time t equal to 0, the plane of the coil is perpendicular to the field. The flux linked with the coil is maximum. So the magnetic flux will be represented as NBA. So we get the flux linkage value of N phi B from the diagram. In a time t seconds, the coil rotates through the angle of theta equal to omega t in anticlockwise direction. So in this position, the flux linked with NBA cos omega t due to the component of B normal to the plane of the coil, and the component of B sin omega t is parallel to the plane of the coil, has no role in the electromagnetic induction. Therefore, the flux linkage with the coil at this deflected position N phi B is represented as flux linkage. So NBA cos theta, already we know that theta represents as omega t, so we can construct the equations from N phi B equal to NBA cos omega t. By using Faraday's law, the induced EMF E equal to minus of d phi by dt. Here phi replaces it as flux linkage, so we can put it N phi B. So minus of d by dt equal to N phi B, we know that NBA cos omega t. NBA is the component of constant, we take it out outside of the outer bracket of, so minus NBA. Differentiate the terms of cos omega t, so we get minus sin omega t, and omega t once again differentiate, we get the value of omega. So induced EMF epsilon, we get the value of NBA omega sin omega t. When the coil is rotated through the angle of 90 from its initial position, and the maximum value of sin theta becomes 1. So the maximum value of induced EMF is EM equal to NBA omega. Therefore, the value of induced EMF at any instant is given by E equal to EM sin omega t. Here, the EMF varying in this manner is called as sinusoidal EMF. Sinusoidal EMF or alternating EMF. This is alternating voltage is given to the closed circuit, the sinusoidal varying to the current flows in it. So the current is called as alternating current and given by the equations of I equal to Im sin omega t, whereas Im is represent as the maximum value of induced current. This is an important questions to asking of 5 more questions repeatedly. In addition, one more important topic of AC generator. AC generator. AC generator is a device which is used to convert the energy of mechanical energy into electrical energy. It converts of the energy purpose we can using of the AC generator devices. Alternator. The alternator produces of a large scale electric power for use in home and industries. We go to see some essential usage of the components of AC generator, likely the names of stator, rotor, alternator, and brush box and slip rings. These are the components of AC generator. The working process of AC generator. First one we go to see principle. The alternator works on the principle of electromagnetic induction. We know that electromagnetic induction is nothing but the relative motions between the conductor and the magnetic field changes the magnetic flux linked with the conductor with in each turn. It induces of EMF. So the EMF produces of induced EMF given by Faraday's laws. By using of to find the Faraday's laws of electromagnetic inductions, we could find the directions of Fleming right hand rule. So first of all, we are going to see the construction. Alternator consists of two major parts, namely stator and rotor. The name suggests stator is stationary while rotor is rotate inside the stator. Once again I repeat, stator is stationary while the rotor rotates inside the stator. If any standard construction of commercial alternators and armature winding is mounted on the stator and the field magnet on the rotor. The first point we are going to see stator. Stator, we are going to the see of diagram. Diagram is not provided here. Stationary part which has a armature windings is mounted is called a stator. It has two components, namely stator core and armature winding. The stator core or armature core is made up of iron or steel alloy. It is a hollow cylinder and is laminated to minimize eddy current loss. The slots are cut on inner surface of the core to accommodate armature winding. The second one, rotor. Rotor contains magnetic field windings. The magnetic poles are magnetized. Where is it? Magnetized to the DC source. The ends of the field windings are connected to a pair of slip rings attached to a common shaft, which rotor rotates. Slip rings rotating along with the rotor to maintain the connections between DC source and field windings to the brushes used in continuously slide over the slip rings. Simply tells us the diagram. Single space AC generator. We are going to see the features of single phase AC generator. And important two more questions. Advantages of stationary armature in rotating field alternator. Here the coil will be in the state of stationary, only the magnetic field will be rotated. So the first advantage is The current is drawn directly from the fixed terminals on the stator without use of brush contacts. In second one, the installation of stationary armature winding is easier. And third one, the number of sliding contacts, which means slip rings, is reduced. Moreover, the sliding contacts are used for low voltage DC source. And finally, armature windings can be constructed more rigidly to prevent the deformation due to any mechanical stress. Next topic, single space AC generator. In a single space AC generator, the armature conductors are connected in series so as to form a single circuit, which generates a single phase alternating EMF, and is hence it's called a single space AC generator or alternator, whatever it is. Diagram. First of all, here P, Q or S be the stationary rectangular coil placed as perpendicular to the magnetic field. The magnetic field acts as horizontal direction. The coil is placed in perpendicular direction. So initially the coil and the magnetic field will be in the state of perpendicular. First of all, we are providing some amount of current through the coil windings. So the coil is produces of magnetic field around it. Initially, the magnetic field will be rotated in the directions of anti-clockwise or clockwise. We are using in this method by using a clockwise direction. Initially, the magnetic field and the coil will be in the state of perpendicular to each other. So the induced EMF will becomes 0. I once again repeat, the magnetic field B and the coil PQRS in the state of perpendicular to each other. So the induced EMF becomes 0 because of the coil and the magnetic field in the state of perpendicular to each other. And the magnetic field will be rotated further the angle of 90 degree in the directions of clockwise. So the field will be moves from here to this position. So in this position, the magnetic field and the coil will be aligned to parallel to each other. So which means the induced EMF will be maximum. So the terminal PQR acts in the directions of downward and RS acts in the directions of upward. So the current flows the directions of P, Q or S. This is first term. And the magnetic field rotate another 90 degree, which means it reaches 90 degree, 180 degree, which means from its initial position. So again, this is magnetic field, this is coil. So the both are perpendicular to each other. So it becomes the induced EMF becomes same value 0. Further, the coil will be rotated again once it means 90 degree. It reaches of the degree of 270 degree. So the coil and the field will be parallel to each other. So induced EMF will be again maximum. Repeated. In this process, the terminal PQ acts in the directions of upward and RS acts in the directions of downward. So the current flows the directions of S or QP in reverse direction. Again rotate the magnetic field in the directions of clockwise. It reaches its origin, which means initial position. So it reaches at the position of perpendicular to each other, the magnetic field and the coil. So the induced EMF becomes as 0. Therefore, the magnet completes the one rotation. Induced EMF in PQRS finishes in one cycle. This is for construction of single phase AC generator. In this diagram tells us the variations of induced EMF with respect to the time of angle. The first diagram tells us the coil, the magnetic field and the coil in the state of perpendicular. So induced EMF becomes 0. Induced EMF becomes 0. The second process, the magnetic field and the coil along the directions of parallel, so the induced EMF will be maximum because of the angle 90. And third process, the induced EMF, when the angle is 180 degree, the induced EMF is 0, which means the magnetic field and the coil is perpendicular to each other. The fourth one, the magnetic field and the coil along same direction, which is parallel. So the angle becomes 3 pi by 2. So 270 degree, the induced EMF is maximum or negative value. It closes negative point of the y-axis. And when the angle is 2 pi or 360 degree, the magnetic field and the coil will be in the state of perpendicular to each other. So the induced EMF becomes 0. This tells us the variations of induced EMF with respect to time angle. Next topic, polyphase AC generator. These questions will be asked in 2 more questions. What do you mean by polyphase AC generator or 3-phase AC generator? Some AC generator may have more than one coil in the armature core, and each coil produces an alternating EMF. In these generators, more than one EMF is produced. Thus, they are called as polyphase generator. And second thing, if there are two alternating EMF produced in a generator, is called as two-phase generator. In some AC generators, there are 3 separate coils which won't give a separate EMF. Hence, they are called as 3-phase AC generator. For example, we are construct a 3-phase AC generator. To see the diagram, initially the simplified constructions of 3-phase generator have a armature core has 6 slots, namely 1, 2, 2, 3, 4, 5, 6. 6 slots are there. Each locks 60 degree away from another. The angle between these and these value of 60 degree, and another 60, another 60. And the slots of the conductor will be joined 1 and 4 in the form of series. The conductor 3 and 6 in the conductor 2 and 5. These coils are rectangular in the shape in 120 apart from one another, which means the coil 1 and 2, 60 plus 60, it produces of angle between the 3 slots of 120 and another 120 and another 120. This is a 3-phase AC generator. And next important point, what are the advantages of using 3-phase alternator? The first point tells us, for a given dimensions of the generator, 3-phase machines produces higher power output than a single phase machine. Second one, for the same capacity, the 3-phase alternator is smaller in size when compared to single phase alternator. The third one, 3-phase transmission system is cheaper. A relatively thinner wire is sufficient for transmission of 3-phase power. And finally, we are going to the important topic of transformer. Transformer. Transformer is a stationary device which is used to the electrical power from to transform electrical power from one circuit to another without changing its frequency. The applied alternating voltage is either increased or decreased with corresponding decrease or increasing of current in the circuit. The transformer converts an alternating current with low voltage into an alternating current with high voltage. It is called as step-up transformer. On the contrary, the transformer converts alternating current with high voltage into the alternating current with low voltage is called as step-down transformer. Next, we are going to see the construction and working process of transformer. First one, principle. The principle of transformer is the mutual inductance between two coils. That is, when an electric current passes through the coil changes with time and EMF is induced in neighboring coil. This is mutual induction process. Construction. Construction tells the simple construction of transformer. There are two coils of high mutual inductance wound over the same transformer core. The core is generally laminated and is made up of a good magnetic material like silicon steel, coil, or electrically insulated but the magnetically linked via transformer core. Working process. First of all, if the primary coil is connected to a source of alternating voltage, an alternating magnetic flux is set up the laminated core. If there is no magnetic flux leakage, then the whole magnetic flux linked with the primary coil and also with the secondary coil. This means the rate of which magnetic flux changes each turn for same of the primary and secondary coils. So applying the primary induced EMF EP equal to minus of NP into d phi by dt. But the voltage applied Vp across the primary is equal to the back EMF. Then Vp equal to minus of Np into d phi by dt. The similar way of secondary coil. So Es equal to minus of Ns into d phi by dt, and voltage Vs equal to minus of Ns into d phi by dt. From the equations point of 4.24 and 4.25, to combining this both of the equations, we get Vs by Vp equal to Ns by Np equal to K. K is called as transformer ratio. In ideal transformer, the input power Vp and Ip equal to the output power Vs and Is. So equating the terms of Vs Vp equal to Ns, Np equal to Ip by Is equal to K, transformer ratio. This equation simply written as 4.27. Already we tells us Vs by Vp equal to Ns by Np equal to Ip by Is equal to K. If Ns greater than Np, then Vs greater than Vp and Is less than Ip. In this case of step up transformer, which is voltage increase and the corresponding current is decrease in reciprocally. The second one, number of turns of secondary coil less than number of turns in primary coil, then voltage in secondary coil less than voltage in primary coil, and current in secondary coil greater than current in primary coil. This is step down transformer where the voltage is decreased and the current is increased. Efficiency of the transformer, it may be asked in 1 mark or 2 mark questions. The efficiency of the transformer, eta of the transformer, is defined as the ratio of usable of output power to the input power. So the transformers are highly efficient devices having their efficiency in the range of 96 to 99%. Various of energy losses to the transformer will not allow them the 100% efficient.